be welding one of these this morning. A double arm machine. It won't be exactly like this one. I'll weld without a space in it. This one was originally a single arm machine that I've added a second one to later, and then there was weld material in there, so I spaced this down a little bit. But a purpose-built double arm machine from the beginning, these are together and there's no space. These are the pieces that I'll use here. This will be the base. This will be the front vertical. This will be the back vertical. This will be the pivot for the tensioner. You can see that that has reinforcement in there, and so does that one to carry the load, so that you don't wear down on the sides of the extrusion. So you get a long wear life out of that. Actually, this is the one. It's already finished. I'm going to use this one. I've already welded this on, and these are the clamps that I'll use. They are a piece of 2x2 by 1/4 inch wall that's been ripped. I will weld these little tabs to them to form a clamp. The clamps look like this when they're done, and they're able to hold the tool arm extremely well without causing any damage to it. And they automatically center the tool arm. It's a very fast, very accurate setup. Don't have to worry about anything slopping or wiggling on you. This is my welder, set up to weld aluminum. Got a aluminum roll in the feeder. It does some real nice aluminum processes. Let's do some fancy welds. This is the feeder gun, aluminum feeder. It's got a little motor in here that pulls the aluminum wire at the same time as the feeder down there pushes, so that you don't end up bending the wire. I cut all the aluminum on this thing. This is a DeWalt table saw. It uses a non-ferrous cutting blade. Okay, so we got everything in place the way we want it. Got my frame ready to go. And I'll start putting welds on it. So I use a bolt to hold these together. Put 2 washers on it for the spacing that I want. Alright, and that will go like this with the handle up. This is just a nut insert that I pounded in there to put steel threads on it. See what I've done? It just centers over there. The spacers create the space, and then I'll weld it right in that position. And I'll weld another one in this position. Tap down because they pull up when you weld. They'll pull up as the metal contracts and it cools. All right, so now I'm gonna weld this one together. I'll put the tabs on it first, and then I will install it on the machine, because it's difficult in its position to weld the tabs once it's on the machine. Alright, so you can see how light that is. That's extremely light frame, but it's very rigid. and has strength in the right places. You got strength there. It's got this box frame here with these nice welds. And so that's a fast, quick frame that's nice and strong and lightweight. Sand off these back edges here so that it fits flush up against that. That's a little sanding glue for aluminum to help keep the belt from clogging. More speed. Okay, so now they're all clamped together. Everything's clamped together so that they're flush there, flush back here, flush on the front, smack together. That way, that way everything squares in relation to each other. So this opening is square to that opening, and when you have the tools in there, they'll be square to each other. Now lay a light bead right across the two of them together that will weld them, the bottom or this edge of them, to the verticals, and then to each other, so they stay lined up with each other. And I'll do one on the other side. I'm going to put a couple of plates on the back here for the motor mount. They don't have to be this big. I just happen to have some of this as scrap. I'm going to weld a couple feet on here. Caps on these ends, tops, cap on this end. This has caps on it. Go on there. Okay, so that slides in and out easy. As soon as you tighten it, it won't budge. Loosen it, in and out easy. Can't budge it. Automatically centers it. Down here I use the little on the bottom, I'll use these little black toggles to keep out of the way of the belt. Because the belt on some attachments will pass down through this area. And so if these orange handles and nubs were sticking out, they would be in the way of the belt. I degrease this area up here. And apply a small piece of UHMW, ultra high molecular weight plastic tape right there. So there's no metal on metal wearing right there. This is a high density plastic, ultra high UHMW, ultra high molecular weight plastic. I'll cut the hole. So you get a smooth function and it doesn't wear out the machine or the metal. To install this, I'll use a stainless steel shoulder bolt. I put a little bit of lube on it to keep the aluminum from galling. This is a really nice lube for aluminum. So the bolt will go in there, precision reamed hole, and then it'll go in here. I'll put some Loctite on the thread. And I tension it so that it will still move, but not be floppy. So there's no side-to-side flop in it. And for the rocker, we've got another stainless steel shoulder bolt. That will go in there. This will go through there. Again, I'll Loctite the threads out there. Steel threads, again, there's a steel threaded insert here for the adjuster knob. There's a steel threaded insert back here to pick that up. And then for the axle that's going to come through here, there's a steel threaded insert there. Then on the frame, I can either add a handle, if I do in a gas spring, and then drill and tap for a gas strut. On my personal machines, I use a linear actuator. Don't judge me on those welds. I don't know what got into that one. And this is my test frame machine, so that gives a lot more control over the belt and over your operation of the machine. You can make tension adjustments while the machine is running. You can make variable tension adjustments to suit each belt. If you got a lightweight belt, you can go with lighter tension. A heavy belt, you can increase tension to get better performance out of it. If you want to do slack belt while you're running, you can slack the belt. All those things with that.